All right, 5.1 angles of triangles. The first thing we're going to do is classify triangles. And you can classify triangles really in two ways. You can classify it by sides and by angles. So just to kind of review some terms. In terms of sides, we have scalene, isosceles, and equilateral. Scalene means that all sides, no sides are congruent. So we don't have any congruent sides. Okay, so if you had a triangle, your markings could look, say, something like this. Okay. Whereas an isosceles triangle has to have at least two sides congruent. Now, a lot of people think it's only two sides, but at least two sides. So an isosceles triangle may have markings that look like that. And then an equilateral triangle, sides congruent. Okay, and so your equilateral triangle may have markings like that. And just note that an isosceles has at least two sides congruent. Therefore, technically, an equilateral triangle is isosceles. It's just a special type of isosceles triangle. It's isosceles triangle with three sides congruent. Okay, and then we can classify by angles. We have acute, right, and obtuse, and then equiangular. Okay, acute means all angles, and I'm just doing some abbreviating, are acute. Okay, remember acute is less than 90 degrees. Okay, so the definition of acute, if we've forgotten that, is less than 90 degrees. All right, and so an acute triangle, just by looks, may look something like that. Okay, where each angle is less than 90 degrees. Whereas a right triangle, you have one right angle or one 90-degree angle. Okay, you would actually want to have that right angle marking put into the triangle. So it might look something like that. Okay, and then you have obtuse. Remember the word obtuse in terms of math means greater than 90. All right, so an obtuse, you have to have at least, or not at least, you have to have one obtuse angle. You can't have any more than one, obviously. Otherwise, you'd have more than 180 degrees. Okay, so an obtuse triangle may look something like that. Just kind of a sketch. There's our obtuse angle. Equiangular, all angles congruent. Okay, so if I'm drawing an equiangular triangle, it may look something like that. That's congruent to that, just congruent to that. And in a triangle, all angles add up to 180 degrees. So that would mean in an equiangular triangle, 180 divided by 3 is 60. Each angle would be 60. All right. Now that we have some of those definitions down, we're going to go ahead and classify some triangles in a coordinate plane. So I'm going to go ahead and plot triangle ABC with the vertices 3, 6, 0, 0, negative 8, 4, and then classify it by sides. And then I'm going to determine if it's right. And I'm going to kind of show multiple steps here. This will be one of the longest problems we do in this video, but it's really important. So we're going to go 3, 6, and plot it, call that A. 0, 0, plot it and call it B. And then negative 8, 4, and there's C. Okay, and got it there and there. All right. So with that triangle ABC, first thing we have to do is we have to figure out if each side is congruent, okay? Or that's one of the things we do first. And so you can do this a couple ways. You can actually find the lengths of the side by using the distance from A to B, like using the distance formula. So let's say I wanted to find AB. I could use the distance formula. Remember, that's D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So given 2 points, point A and point B, if I call this, say, x2, y2, and x1, y1, I could go ahead and do some substitution here. x2 is 3 x1 is 0. We're going to square that, and we're going to add it to y2, which is 6, minus y1, which is 0, and square that. So in terms of our distance, we get 3 squared plus 6 squared, or you have to add those, square them, and then add them. You can't just take the root of each of them. So that would be 9 plus 36. Okay, the square root of that, and that would be equal to root 45. Okay, so that means this side, A to B, has a length of root 45. Okay, so you could do it that way. You could also, if you chose to, you could use a right triangle. So if you have a picture and you want, you could just use the Pythagorean theorem. You could say, well, if I want to find from C to B, I could use A squared plus B squared equals C squared. And I use that by making a right triangle here, connecting A and B. And really, that's using the slope. So I decrease 4, this length is 4, and I go over 8, that's 8. And remember, that's A squared plus B squared equals C squared. So if I square this side, that's 16. If I square this side, it's 64. And 16 and 64 happens to be 80. And so the square root of 80 is that length. Okay, so I know that's this root 45. I obviously know those aren't congruent, but maybe this side is. So, let's go ahead and, I'm going to go ahead and use the distance formula to find this last one. So to find A to C. A to C, I'm going to take the distance. Let's go ahead. We'll keep this as x2, y2. Let's call this one x1, y1 when we're dealing with point A and point C. Okay, so I'd have this time 3 minus negative 8, okay, squared, plus, and then have y2, so 6, and y1 minus 4 squared, okay, and now it looks like it's going to be this double negative, which is plus, so 3 plus 8 is 11, so I have the square root of 11 plus squared plus 6 minus 4 is 2, so 2 squared, so I get, oops, I hit my controls there, so, okay, I end up with the square root of 121 plus 4, which is 125. Okay, so root 125, so this length is root 125. Obviously, it is not root 80 or root 45. So those sides are not congruent. Therefore, this triangle is a scalene triangle. When we're classifying triangle by sides, scalene. Okay, now if I'm determining it right, you're using slope to deal with that. You're trying to find if you have any perpendicular lines, and the ones that actually look perpendicular possibly are AB and BC. Now, I'm going to also show you kind of a shortcut for finding out what type of triangle it is. Since it doesn't actually say what are the lengths of the sides, and you just want to know if they're congruent, well, that's dependent upon the slope. So notice if I were to draw in the slope right here, my rise and run, okay, I run 3 here, and I rise, looks like 6, okay? And my rise and run here looks like I rise 2 and run 11. So that'd be like 2 and 11, okay? So let me go ahead and list the slopes, and I'll explain here. So let's say I want to find the slope of BC. So M is slope, and I'm just putting a sub BC to kind of explain that. So I go down 4 and over 8. So my slope is negative 4/8, also known as negative 1/2. Okay, let's say I want to find the slope of AB. Okay, well, AB looks like I rose 6, so I'm going from left to right, so I rise 6 and I run 3. 6 over 3 is 2. And then let's go with the slope of AC. Okay, it looks like from C to A here, from left to right, I'm reading my line. Okay, I'm rising 2 and running 11. 2, 11. Okay, well, since my distance is based on the Pythagorean theorem, and the lengths of these sides are based on the distance, then really, because I'm using these right triangles to help find this length or this distance here, if these slopes are all different, or the absolute value of these slopes are all different, so like excluding negatives, So I had to have 1/2, 2, and 2/11. Since they're all different, that means these side lengths must be different as well. So that's kind of a shortcut there. It means it's scaling. Now, if you had slopes that were the same, that would mean the lengths were the same, meaning you might have isosceles or equilateral. Okay. The other thing we need to do is find out if it's a right triangle. Now remember, if it's a right triangle, you would have perpendicular lines. And perpendicular lines have inverse reciprocal slopes. Okay? So in other words, if you take your slope, -1/2, and then you flip it, that would become 2/1, and then take the inverse, which makes negatives positives and positives negatives, means the inverse reciprocal of -1/2 is 2, which happens to be that. So these are perpendicular. Okay, that means perpendicular. So BC and AB are perpendicular. That means they intersect at a right angle, meaning, yes, this is a scalene right triangle. All right. There we go. Let's go ahead and look at some other stuff here. So first, triangle angle sum theorem. Let's go ahead and go through some theorems here. Triangle angle sum theorem just says all angles of a triangle have a sum of 180 degrees. So that plus that plus that, those all add up to 180. Now, the corollary to the triangle angle sum theorem, as I like to say, the cousin to it, its cousin, says that if the triangle is a right triangle, then the two acute angles, so we're talking about this angle and this angle, have a sum of, well, if that's 90 and all of them add up to 180, you've already used 90, you only have 90 left for these two. So have a sum of 90 degrees. There we go. Okay, so that is the corollary to the triangle angle sum theorem. I like to think of it as like the cousin of it. All right, the last one says the exterior angle theorem. All right, so what I'm going to take a look at, I'm going to highlight some angles here. So let's say I have this angle right here, that straight angle right there, and that straight angle right here. And now remember, straight angles add up to, or straight angles form 180 degrees. So this straight angle is 180. This straight angle is 180. And this straight angle is 180. That means through all of those measures right there, I have a grand total of 180 degrees times 3, which is 540 degrees. Okay? Well, the exterior angle theorem states that, well, it's asking me to find the measure of, let me put some different colors here. It's trying to find the measure of your exterior angle. So that angle, this angle, and this angle. Okay? So we want to find the exterior angles. All right? Well, let's keep in mind that we know that this angle and this angle, these straight angles add up to 180. And if I take into account that this is a triangle right here, notice that triangle, let's call this angle A, angle B, and angle C. Angle A plus angle B plus angle C has to add up to 180 by the triangle angle sum theorem. So if I take out this angle and this angle, which we're calling A and B, and then this angle, that 180 degrees, if I take that off of the top of the 540, Take it out of 540, I'm left with 360 degrees. And that 360 degrees is the sum of your exterior angles. Okay? So the exterior angle theorem states that the sum of the exterior angles of a triangle is 360 degrees. And just so you know, that's actually the sum of any exterior angles of any shape. The sum of the exterior angles of a square or a 20-sided figure will always add up to 360, and you can kind of prove it the same way. Okay? All right. Well, let's try a couple other things. We're almost done. So this one right here, find the measure of the indicated angle. So we're going to use some of this theorem, some of the stuff we learned here. So I know that I have 137, I have 102, and I'm trying to find this question mark. Well, it'll help if I could find this angle measure and this angle measure, because once I find this angle measure, I then could use both of those in 180 to find this angle measure, and then these two make 180. Okay? So, and I'm going to hit on one other type of theorem here. So 137 plus whatever this is. So I'm going to call it angle A. So I know that the measure of angle A plus 137 degrees has to be 180 because it makes a straight angle. Meaning the measure of angle A that I labeled angle A is 43 degrees. I just subtract 137 from both sides. Okay? So now I have a 43 degree angle here. Now I can say, well, 43, 102, and let's call this B. Okay? If I say, well, 43 plus 102 plus the measure of angle B is equal to 180. How come? Well, because they make a triangle. Right? Okay? And so that means 43 and 102, which is 145, plus the measure of angle B is equal to 180, meaning the measure of angle B is actually 35 degrees. And then, let's go ahead and note that this makes a straight line. Therefore, I know that the measure of angle B, or 35 degrees, plus my question mark is equal to another 180. Therefore, my question mark, subtract 35 from both sides, is 145 degrees. This is 145. Now, the important thing to note here is we saw that 145 somewhere else. That's what they wanted, but notice we see it right there as well. And what was that 145? Well, that 145 represented 43 plus 102. And what did 43 and 102 represent? It represented these two angles. Okay? This relationship's always going to be the same. The measure of your exterior angle is the sum of the measure of, we call these remote and interior angles, or the two non-included angles. So if we take the sum of the two non-included angles, those are called remote interior angles. That's going to equal the exterior angle measure. Okay, so the sum of these will equal that. You're going to use that quite often. So just be aware of it. Keep referencing this. All right, let's try another one here. I'm going to walk through this one fairly fast, okay? First thing I'm going to do, I need to find this question mark. So one thing I could do, I recognize right away, hey, this is a triangle. I know two angles, so I automatically can find the third. 20 plus 35, those two combined make a grand total of 55. And 55, 180 minus 55 tells me that this is 125 degrees. Okay? I can then use that 125 and write it here because I have vertical angles. Vertical angles are congruent. All right, to find this, well, I'm going to have to use this relationship. Well, 156 plus something equals 180. Well, if I subtract 156 from 180, I find out that this is 24 degrees. And now I know that 24, 125, and something is 180, or 24, 125, which is 149. 180 minus 149 is that angle right there. That is 31 degrees. All right. There we got it. So it's almost like a little puzzle, you know? Okay, 2 more problems and we call it good here. All right, so find the measure of angle A. Note I have a right triangle. Since this is 90, all angles add up to 180. Remember our cousin theorem. Remember our cousin theorem we talked about earlier? This one right here. Angle is right angle, or right triangle, then the 2 acute angles have a sum of 90 degrees. Well, let's take a look at it then. This and this have to add up to 90. So x plus 37 plus x plus 67 equals 90, which means 2x plus 37 and 67, also known as 104, equals 90. 2x equals negative 14. Subtract 104. X is negative 7. How is that possible? Well, we're actually finding the measure of the angle A. If x is negative 7, measure of angle A actually equals x plus 37. So I can put in a negative value for x as long as my angle isn't negative. I'm good. And here my angle actually happens to be 30 degrees. So that is okay. This angle, 30 degrees, which by the way means this angle better be 30, 90. This one better be 60. And if you double checked it, yeah, negative 7 plus 67 is 60. So we're good. Measure of angle A is equal to 30 degrees. All right, last one. Taking a look at this, I'm going to go ahead and use vertical angles to move this angle here, 4x plus 17. And now I know this angle, angle A, and 80 have to add up to 180. So 4x plus 17 plus x plus 23 plus 80 equals 180. Now some of you may just have started out by going, okay, actually I know that 4x plus 17 plus x plus 23 is going to equal 100 because I'm going to take 80 away from 180. And some of you would even combine these first. You'd say, oh, that's actually 5x. And 17 to 23 is actually 40. And that is equal to 100. Which means 5x equals 60. So 1x is 12. So x is 12. They're not actually asking for x. Remember, they're asking for angle A. So measure of angle A is equal to x plus 23. And that means that we have 12 plus 23, which is a grand total of 35 degrees. So measure of angle A, 35 degrees. That's all I got for you. All right, hope it helped. Good luck.